Hi guys, were you able to solve this question? Let's check it out. Initially, I was thinking that why not to substitute x as tan theta, because if x is tan theta, then 1 minus tan square theta, basically I'm substituting x over here. So that was my approach 1. That it will become 1 minus tan square theta over 1 plus tan square theta. So this expression we know it's a double angle identity, right? So that can be turned into cos of 2 theta. Fair enough. We have reduced this. This x will remain as tan theta, and we are now interested in finding dx as well. So dx will now become sec square theta d theta. So how will the integration gonna look like? X is replaced by tan, so this is tan theta. This is square root of 1 minus uh, and we know that this complete stuff has been simplified to cos of 2 theta, right? So this will be root of cos of 2 theta, and then we have dx. So dx is going to be sec square theta d theta. But after reaching here, I was kind of not sure that how to proceed, because this is a radical, right? And I need to take this cos 2 theta out of this radical, which I do not think is that easy. That's why I thought of another method which is pretty straightforward, and that's a really simple substitution which we have to use out here, and pretty much intuitive as well. Because if you notice, we have an x outside and we have an x square inside. So why not to substitute x square as y, right? So if we substitute x square as y, then if we differentiate both the sides, basically it's going to look like 2x dx is equal to dy. And we know that we have an x dx outside, so let's find it out as we know x dx is going to be, dividing both sides by 2, so it's going to be 1 over 2 dy. So this is what we are going to take and keep it separately. All right. Now the next thing which we have to do is, of course, to rewrite the complete integral. This is method 2, by the way. To rewrite the complete integral in terms of y. So we know that x and dx, x dx can be replaced with 1 over 2 dy. So that's what I'm going to do. It is replaced, it's rewritten as 1 over 2 dy. So I mean, it looks good if we write dy at the last, so that's why I've written it at the last. And now I will write this particular expression. So that's going to look like root of 1 minus y over 1 plus y. All right. So yes, we are not definitely so comfortable with these radicals. So let's try to get rid of the radical. Get rid of the radical, and the best way is, I think, to rationalize. If we think that if we are actually interested to rationalize, so this is what it's going to look like as of now. And if you want to rationalize, the numerator remains as it is, denominator remains as it is, and I'm going to multiply by root of 1 plus y. I'm going to divide by root of 1 plus y as well, and this dy, however, remains as it is. All right, let me try to make some space over here. This is going to look like 1 over 2 integration of, now definitely everything can be taken inside just one square root, so that's going to look something like this, and this will become 1 plus y only, and this is dy. And this will become 1 over 2 times root of 1 minus y square over 1 plus y dy. Okay, what do you think we should do now? I think that it's a good idea if we can substitute y as cos or perhaps sine, because 1 minus cos square or 1 minus sine square we know can be easily it can be easily simplified. So that's what I'm going to do now. I'm going to make another substitution of y as cos of theta. This means that dy is going to be minus of sine theta d theta. So how will the integration going to look like? It's going to look like 1 over 2 integration of root of 1 minus cos square theta over 1 plus cos theta, and dy is going to be minus sine theta d theta. Fair enough. This negative, let's take it out. So this will become negative 1 over 2, and we know that 1 minus cos square theta is sine square theta, so that's going to look something like this, root of sine square theta, and this sine theta remains as it is, this d theta remains as it is from here, and this will become 1 plus cos of theta. All right, okay. Root of sine squared theta is gonna be sine theta. But the question to you is, why is that not minus of sine theta? Because root of sine squared theta is basically absolute value of sine theta. So why am I writing just sine theta and not sine squared theta? That's for you to think, and you can comment on the comment section. Uh, so this is sine theta times sine theta over 1 plus cos theta. So that's going to look like negative 1 over 2 root of sine squared theta over 1 plus cos theta. And I think now you know what we have to do. We have to again manipulate this particular identity. This identity to gonna look like, this will become negative 1 over 2, and sine squared theta is what? 1 minus cos squared theta, right? So that's going to be 1 minus cos squared theta d theta over 1 plus cos theta. All we have to do is use the difference of the perfect square identity. So that can be written as 1 plus cos theta times 1 minus cos theta d theta over 1 plus cos theta. So one of this expression gets reduced or cancelled, and all we are left with is negative 1 over 2. This is 1 minus cos theta d theta integral, which can be easily integrated, right? So that's going to be negative 1 over 2 theta minus integration of cos is sine. Remember, it's not minus sign, plus c. Let's open up the parentheses. So that's going to look like negative 1 over 2 theta plus 1 over 2 sine theta plus c. And it's always a good idea to rewrite all the final answer in terms of the original variables, right? So what was sine theta, by the way? Okay, cos theta was y. So let's write it over here once again. Since cos theta is nothing but y, which means that theta is nothing but cos inverse y. That's one thing which we need. If cos theta is y, then cos squared theta is y squared, which means that cos squared theta is nothing but 1 minus sine squared theta. So 1 minus sine squared theta is y squared. If we rearrange, then 1 minus y squared is sine squared theta. And if we take square root both the sides, then root of 1 minus y squared is going to be equal to sine theta, which is exactly what we needed, right? So we're going to substitute that over here. So it's going to look like negative 1 over 2 cos inverse y plus 1 over 2 root of 1 minus y squared plus c. But even y is not our original variable. Original variable was x, and we know that y is nothing but x squared. So all we have to do is replace y with x squared over here. So the final answer becomes negative 1 over 2 cos inverse x squared plus 1 over 2 root of 1 minus x raised to 4 plus c. I hope you enjoyed this video and learned from it. Thank you very much.